This video is about the process of calculating convergence. We'll give some options. We'll review the process we discussed in another video, and then show these additional options. And we'll discuss the new options a little. Let's get started. In our previous video about calculating convergence, we discussed three sets of equations, and depending on the value of the subscript k, you can use one of the sets. Here is one of the sets. It has an equation for p sub k, the numerator of the kth convergent, and it has an equation for q sub k, the denominator of the kth convergent. This set of equations works for any subscript k, but it is necessary to have p sub k minus 2 and p sub k minus 1, and q sub k minus 2 and q sub k minus 1. So we need the two previous convergents. This is where the other two equations come in. These sets provide a way to calculate what we need, two values of p and q, so we can get started. This set works for k equals minus 1. We put k equals minus 1 in quotes because there isn't really a subscript k equals minus 1. It's just something people contrived to facilitate getting started. And this set of equations works for k equals 0. The way this works is you use these two sets of equations to get two convergents, one for k equals minus 1 and one for k equals 0, and then you have what you need to use this set of equations starting with k equals 1 and for all remaining values of k. Here are the other two options. They provide additional ways to get the first two values. One set is p sub minus 2 equals 0 and q sub minus 2 equals 1. And this one is p sub 1 equals 1 plus a0 times a1 and q sub 1 equals a1. This one to the left, as you can probably guess, works for k equals minus 2, which we put in quotes because there really isn't a k equals minus 2. Don't worry about that. And this set works for k equals 1. What you can do now is pick any two consecutive sets of equations from these four sets, and then you have what you need to start using this set of equations. You can use these two for k equals minus 2 and k equals minus 1, and then use this set starting with k equals 0. Or you can use these for k equals minus 1 and k equals 0, and use this set starting with k equals 1. That's what we did in the earlier video. Or you can use these two for k equals 0 and k equals 1, and use this set starting with k equals 2. Now let's discuss this a little and see how it all holds together. We can make a table, like usual, for calculating convergence. We have rows for k, a, p, and q. K is the subscript. The row for a has the kth term from the simple continued fraction, and p and q are the numerator and denominator of each convergent. We'll put these four sets of equations in, so k starts at minus 2 and goes up to 1. When k equals minus 2, we don't have anything to put in the row for a, but we can use this set of equations to fill in the values for p and q. They are 0 and 1. When k equals minus 1, we once again do not have anything to put in the row for a, but we can use this set of equations to fill in p and q. They are 1 and 0. In the next two columns, we can add a0 and a1 in the row for a, and in the column for k equals 0, we can use this set of equations for p and q. They are a0 and 1. Finally, in this column, we use a set of equations p equals 1 plus a0 times a1 and q equals a1. Suppose we're calculating convergence using the first two sets of equations, these two. We could fill in these values here using the equations and then use this set of equations starting with k equals 0. To get p0, you would add this to this times this. That's 0 plus 1 times a0 equals a0, which is the same thing we have if we were using this equation. And for q, you'd add this to this times this, which is 1 plus 0 times a0, which is 1. Once again, it's the same thing we already have from this set of equations. Now we can use these two sets of values and see what happens if we use this set of equations to calculate the convergence when k equals 1. Pause the video and try to do it yourself. For p1, you would add this to this times this. It is 1 plus a0 times a1, the same thing we already have from this set of equations up here. And for q1, you would add this to this times this, which is 0 plus 1 times a1. It equals a1, the same thing we already have from the equation. So all of this holds together nicely. After this, whichever two you use to get started, you will use this equation. You might be wondering which option you should use. That's a personal preference, really. You could make your choice based on what you think is easiest to use or easiest to remember, Or maybe you don't like using equations for k is less than 0 since they're contrived for doing the calculation, or maybe you do like that. One thing I'll point out is it's pretty easy to derive either of these two sets of equations if you forget them. We can write out a generic simple continued fraction like this. The convergent for k equals 0, p0 over q0, includes the a0 term, but we truncate everything else. So it's a0 over 1, the same thing we have in this set of equations. And when k equals 1, p1 over q1 includes a0 and a1, but we truncate everything else. So it's a0 plus 1 over a1. This equals 1 plus a0 times a1 over a1. We can see that the numerator and denominator are the same thing as what's in the set of equations for k equals 1. I'm not saying you should use these two sets to get started. I'm just saying you can derive them. I usually use these two sets, and that's what I showed in the earlier video. But it's just a personal preference. In this video, we saw some options for finding two values of p and q to get started on the calculation of convergence, and we saw how the various options lead to the same results. That's all for now.